Okay, our second subtopic, which is on electron diffraction. So in this subtopic, you should be able to describe the observations of electron diffraction in Davison gamma experiment, explain the wave behavior of electron in an electron microscope, and relate it with the de Broglie wavelength of electron with the resolving power of the microscope, and lastly state the advantages of electron microscope compared to the optical microscope. Okay, so this one there is no calculation. This is basically just understanding, comprehension lah. Okay, so I am pretty sure there will be no questions on the second subtopic lah, tapi sometimes they would ask you about this one. Okay, right, so Davison gamma experiment, this is the tube which demonstrates the electron punya diffraction. Okay, so this is our K dot and then this is our A naught. So there's a graphite film here, so the electron is being incident here, so the electron is then diffract, so it goes onto the screen and there's a diffraction pattern being seen on the screen lah. Okay, so this experiment proves that the de Broglie relation was right and the wavelength of the electron is given by this equation here. Okay, so if the velocity of the electrons is increased, the rings here becomes narrower. Okay, so what does that mean? It shows that the wavelength of electrons decreases with increasing velocity as predicted by the de Broglie relation. Okay, so the velocity of electrons is controlled by the applied voltage V across this K dot and A naught. Okay, so the equation to calculate the speed of the electron is shown here. So if we substitute lambda into V here, it will then becomes this equation here. Okay, right, so if they ask you about the voltage, you can then use this equation. If they ask you about the speed, you can use this equation. Okay, so note that electrons are not the only particles which behave as waves. Okay, and then the diffraction effect are less noticeable with more massive particles because of their momenta, which are generally much bigger, so the wavelength is shorter. Okay, so you can't really see the pattern on the screen. Okay, so diffraction of the particles polar are observed when the wavelength is of the same order as the spacing between the plane of the atom. Okay, now let's look. This is an electron microscope. Okay, so electron microscope is a device that relies on the wave properties of electrons. Okay, so it is similar to optical compound microscope in many aspects. Okay, but the advantage over the optical microscope is that the resolving power of the electron microscope is much more higher than the optical microscope. Okay, so why? Because the electrons can be accelerated to a very high kinetic energy, giving them a very short wavelength. Okay, so because of that, the diffraction effect are much more less than that of light lah. Okay, so we can then be able to distinguish details about 100 times smaller. Okay, so in operation, a beam of electron will fall on a thin slice of sample. This is actually my research during my degree in the UK. So in the UK, they have the electron microscope. Like, I don't actually remember exactly the term, but this is my bone cement which I use electron microscope lah. Okay, so what it did was a beam of electron falls on this thin slice of sample. So I've put a sample in kind of like a box, if I'm not mistaken, or is it a cylinder? I don't really remember. But then that sample, a beam of electron would go onto this sample lah. Okay, so the sample to be examined must be very thin lah, sangat thin. Why? Because we want to minimize the effect such as absorption or scattering of the electrons. Okay, so the electron beam is controlled by electrostatic or magnetic lenses to focus the beam to an image, and the image is formed on a fluorescent screen. So there are two types of electron microscope. First one is transmission, which produces a 2D image, scanning, which produces image with a 3D quality. Okay, so this is a diagram showing the transmission of electron microscope and the scanning electron microscope. Okay, so these are the example of when the electron microscope is used lah. Okay, so you can see clearly the structure, okay, the structure of this bone cement. Okay, all right, yes, that is basically our last, this is the last topic for this chapter lah. Okay, and that is on electron diffraction.